Alright, today I'm going to show you how we can find the surface area of prisms using an actual formula. So we have been looking at prism nets, and if you look at that, what that looks like, here are pyramid nets that we've talked about. When we talk about prism nets, something like this, where we could take this triangular prism right here, and if we were to unfold it, and we could find the lateral surface area or just the faces, and then we could also find the total surface area, which means the lateral surface area and the bases. So really we had to find the area of each shape and then add those all up. So it could be a little time consuming. So we did a couple of examples like that. So we had over here in a rectangular prism, the bases are always off to the side. The faces are the rectangles, and they're going to be side by side in a prism. Here again, these are my two bases because it's always the two shapes that are off to the side in a prism net. And then your rectangular faces are going to be your lateral sides right here. And then here's another example of a triangle prism. So this is what it looked like when it was going to be a net. So what I'm going to show you how to do, instead of having to find the area of each of those shapes and then adding them all up, there's actually a formula we can use. And the reason we showed you with the nets first is so that you could understand how this formula came up. So let's review a little bit of vocabulary before we get started. So in case you forgot, the bases in a prism are going to be parallel from each other. So these are going to be parallel from each other and the same shape. So in the prism net, where we just looked at the bases would be off to the side, but this is relating if this was a three-dimensional figure, which we're going to look at two examples here in a minute. So those are going to be parallel from each other and the same shape once they're folded up. Okay, so it's what you're going to see two of. So in a prism, there's going to be two bases. Then when we talked about the lateral surface area was going to be the area of the faces, but not the bases. So it doesn't include those bases. So remember, in a prism, all your faces are going to be rectangles, so it's going to be all those rectangles that are side by side. Then your total surface area, that's going to be your lateral surface area. Lateral surface area. And the area of the bases. That means everything. So again, if we had that as a net, if we were to unfold it, every shape that you see, you find the area of each one and add them up. But again, that can be a little bit time consuming. So let me show you what we're going to see on our math chart that we're going to be able to use as the formula. So in order to find the total surface area for any prism, this is the formula we're going to use. S equals PH plus 2B. And that's a capital B. We're going to talk about those elements of each of that. So you don't have to memorize this formula. This formula is actually going to be on your math chart that you're going to be able to use on your test. So what the S stands for is surface area. But not just surface area. I'm going to put this in parentheses. It actually means our total surface area. So not lateral surface area. If it was just lateral surface area, that just means the area of each of those faces. The P stands for the perimeter of the base. The capital B stands for the area of the base. And the H, the lowercase h, is going to stand for the height of the prism. Whether it's a rectangular prism, triangular prism, hexagonal prism, anything like that. And just so you remember, the height of the prism is going to be the distance between the bases. So we're going to talk to you about why this perimeter element is here, because we haven't even talked about that yet since we haven't used a formula. Okay? If you want to find just the lateral surface area, then that's going to be this formula right here, S equals PH. Okay? So in this situation, so I know that seems a little weird. You're like, well, this S, how do I know which one it is? So in this situation with this formula, it stands for total, because if you look at it, if this is your formula for just lateral surface area, didn't we say that the lateral surface area plus the area of the bases? If you stop and think about previous lessons we talked about, the lateral surface area plus the area of the bases is going to get you your total surface area. So I like to put TSA for total surface area, lateral surface area for LSA for lateral surface area. So that's something we've talked about in previous lessons. So your total surface area is going to be your lateral surface area plus the area of the bases. So if this capital B means the area of the base, and every prism has two bases, that's why we're multiplying it by 2. Okay? So let's look about when we're solving just for the lateral surface area. So I'm going to put lateral right here. So if a problem just says, what's the surface area, that means that they want total. If they want specific lateral surface area, they're going to give you that keyword. So we'll help you out with that. So here are your steps for when you start finding the surface area, whether it be lateral surface area or total surface area. Here are your steps. The first thing we need to do is determine the shape of the bases. And the reason why we have to determine the shape of the bases, 2 reasons, but the main one, so we know how to name it. Okay. If the 2 bases are a triangle, that's going to be a triangular prism. If the 2 bases are rectangles, it's the rectangular prism, and so on and so forth. The other reason that we need to determine the shape of the bases is if we're looking for the lateral surface area, then you have to figure out just the faces, not the bases. So this is for when solving for lateral or actually the total surface area. Either way, we're going to need to know the bases. So after we've identified the bases, we're going to write the formula. And we're writing the formula according to what we need. So if we need the lateral surface area, we're going to use this one. If we need the total surface area, we use this one. You always start with your formula. Then the last step is substitute the numbers. Substitute numbers and solve. So this is why you should always be working these problems out step by step, not just typing numbers into your calculator, because if and when you do make a mistake, we don't know where you made that mistake if we don't see it. Okay? So this is going to be off to the side that I'm going to reference to, but again, definitely need to know this vocabulary. So let's look at 2 examples. So what we've been practicing is when we found lateral or total surface area, this was all unfolded as a net. So I'm going to go ahead and show you how you can do it without using that and with using the formula. So for example, there's 1, 2, 3, 4, 5, 6 rectangles here, right? So we know for sure all of these shapes are rectangles, so it is going to be a rectangular prism, okay? So the shape of the bases, well, I see all 6 rectangles, so I'm going to say that this is a rectangular prism. Because like I've told you guys in the past, if you actually see 2 of it, whatever you see the least amount of, is actually going to be the bases, but in this one we have all 6 are rectangles, so that definitely makes it a rectangular prism. Because I switched these around. Okay? So the shape of the bases were rectangles. I'll just cross this out. We'll switch it over here. Name of shape. and then shape the base. So on your papers, yours may be right. Mine just got a little jumbled up. That's okay. So if the bases are rectangles, that's why it's a rectangular prism. So just read carefully on that. All right, so let's keep going. Now here's the deal. If it's a rectangular prism, like we've talked about, any of these two rectangles could technically be the bases. It just depends on how we unfold it. So I'm just going to say, okay, well, what if I shade this? Because we always want to trace or shade the base first. Let's say that I did these as the bases. Okay? In a rectangular prism, it really does not matter which two rectangles that you label as the bases. The only thing that could have effect on is your lateral surface area, but it's not going to affect your total surface area. So let me show you what I mean by that. So if I said this was my base right here, and I'm just going to use this blue color to help me out, I know that I'm going to have to find the perimeter of that and the area of that base. Okay, so let's start with our formula. So back here, we have our total surface area and our lateral. I'm going to actually start with the lateral surface area first. So the lateral surface area is S equals PH. Okay, so if we did this with the net, we would have said, okay, this one is 8 by 5, which is 40, and over here is 40, but those are the bases, so we don't want to include that. If we wanted lateral surface area, stop and think about it. 12 by 5, that one right here is 60, and this means that this rectangle up here is also 60. Then you have this front one right here, which is 12 by 8, so 12 times 8 is 96. So that front rectangle and the back rectangle are the same. So if you stop and think about it, that's 96 plus 96, and then 12 by 5 was 60 plus 60. If we were to do that the old school way when we're doing the nets, we could have seen 6 plus 6 is 12, 9 plus 9 is 18, 19, and then plus 12, 12, 13. Just use my calculator, just double check, save some time so we can make sure we got this. 96 plus 96 plus 60 plus 60. So the old way that we were doing it, we would have said that our lateral surface area was 312. And what I did with that is I ignored those bases, and I saw those 4 rectangles were my faces. So if I were to unfold it, so again, 12 by 5, that bottom rectangle, 12 by 5 is 60. That also is the same dimension as that top rectangle. Then that front rectangle right here, 12 by 8, is 96, so that would be that same one as in the back. So we added them up. That takes a little time, so you had to find the area of 4 rectangles and then add them up. Well, watch this. If we looked at this one using our formula, the perimeter of the base, well, the perimeter is everything on the outside, so that would be 5 plus 8 plus 5 plus 8 right here. So 5 plus 5 is 10, 8 plus 8 is 16, so the perimeter of the base is 26. Then the height, again, the height right here, what that H stands for, is the height of the prism, so that's the distance between the bases. So what's that connecting is this amount right here. So that is actually your height, connecting the bases. So if we substitute the number in, we say 26 is my perimeter of the base times 12, the height of the bases, or excuse me, the height of the prism that's connecting the bases. We should get this number. Let's check it out. 26 times 12, sure enough, get 312. So a lot of ways, though, now we know this formula, this is why it works. We could have unfolded it and made the net and found the area of those 4 faces and added them up, but now we can see that this formula works, so we can use that moving on. This one didn't say if it's centimeters, inches, or feet, so we're just going to say units squared. Because it is area, we're going to take it to the second power. Because what you ultimately did is you multiplied 26, that perimeter right there. When you add, you just keep your units as that one dimension, but when we multiply again, units times units, it's units to the second power. So let's talk about this total surface area formula. So if I said, and I'll use green for this one, so my total surface area, so this is where you have to be careful. This one just says S, and so does this one. So depending on what you're looking for, you got to write the correct formula. So your total surface area is S equals pH plus 2B. And again, that makes sense because this first part is that. That's your lateral surface area. And that second part, with capital B, stands for area of the base. And you have two of those bases in a prism, so that's why you're multiplying by 2. So again, old school, if you want to think about it that way, this was my lateral surface area that we've already figured out if we were to unfold this, right? So now if we're including this, well, now we want the bases. So 8 times 5 is 40. 40 plus 40 is 80. So if we were to add 80 to that, we would get 392. So again, this is if we were to unfold it, find the area of every single rectangle and add them up. But let's prove it with that. Let's see if that's what happens here. So S equals, well, the capital P, we already figured out, was 26 because the perimeter of that base was 26 times the height of the prism is still going to be 12. The height's still connecting those bases, plus 2 times the area of the base. Well, if your base right here is a rectangle, so I'm going to say capital B equals rectangle. Capital B really means the area of the base, but I just like to identify the shape first. So it's base times height of your rectangle. Well, your base of the height and height are 5 and 8. So 5 times 8 is 40. Okay? So that's what we're looking at. So if I go ahead and substitute this in, well, 26 times 12, we've already figured out, was 312. And then we're going to add 2 times 40, which is 80. Sure enough, 312 plus 80 is 392. And that's what my prediction was, kind of taking it back to thinking if this was a net, if we were to unfold it. Now here's the thing, and I'm going to show you this in this example right here. Okay, this will be in the scanned copy of your notes as well. It doesn't matter actually which two rectangles that you identify as your bases. These are some notes that I had done another time. So if I had shaded these two in pink and said that those I thought were my bases, that would be okay. I would still get the same total surface area. The only thing that would be different would be the lateral surface area. Okay, so that's something to think about. So just be very mindful and be very careful. If they're asking for lateral surface area, they're going to be more specific on what your bases are. But if they're asking about total surface area, you could actually choose any of those. Okay, so you can pause the video and look through those. What I did with the pink, that was just finding the total surface area there. Or definitely ask your teacher as well. Okay, let's do a second example so that way you can get some done on your own. And I know I'm giving you a lot of information, but again, I want to kind of relate back what we did before. If we were to unfold this and make it a net, how we were doing that, you find the area of all 4 rectangles for the lateral surface area, or in this case, all 6 rectangles for the total surface area. So this is why these formulas actually work. Okay? All right, so let's look at this one. The shape of the bases. Well, I see 2 triangles and 1, 2, 3 rectangles. So again, whatever you see the least amount of are actually going to be the bases. So that's going to be shape of the base. We're going to say triangles. So if the bases are triangles, that means this is going to be a triangular. Well, there's 2 bases, so it's not a pyramid. It's a triangular prism. Okay, remember triangular prisms have 2 triangles as bases and all the other faces are rectangles. Triangular pyramids have 1 triangle base and all the other faces are triangles that are going to meet up and fold at the vertex. So that part's going to be coming up later on. Okay, so we're going to go through our steps again. Here are my steps on that other paper. First, determine the shape of the bases, which we just did. They're triangles. We're going to write the formula for both our lateral and total surface area. Then we're going to substitute those numbers and solve. Okay? So the first thing I would do, shade the base. So those are my triangles. Again, we could unfold this And those three faces would be the rectangles, so that's how we're going to find the lateral surface area. But instead of having to find the area of three rectangles, we're just going to use our formula that we know now, S equals pH. So S equals pH. I like to find the lateral surface area before the total surface area because this is part of this equation. So the capital P stands for perimeter of the base. So the perimeter of the base, if you kind of fold that up like that, well, I see 10 and I see 8, but if you stop and think about it, this triangle right here is opposite, parallel, and congruent, so that's also 10. So my three sides are 10 plus 8 plus 10. So 10 plus 8 plus 10 is 28 centimeters. Then H is the distance connecting the bases. Again, I know that all from these notes right over here, just knowing those definitions. So the distance between triangle to triangle in this triangular pyramid, so if this was spaced out like that, is 12 centimeters. So now I can substitute that information in. So the perimeter of the base I saw was 28 times the height of the prism connecting those bases is 12 centimeters. So I can go ahead and do my math. 28 times 12. 28 times 12 is 336. So centimeters times centimeters means centimeters to the second power. So my S is 336. Now in this situation, the S stands for lateral surface area. Okay, so let's go ahead and look at total surface area. So if I wanted to find the total surface area, I'm going to say S equals 2, I'm sorry, not the 2 yet, S equals pH, the lateral surface area, plus 2 times capital B. I could have put 2B plus pH, but I want to keep it consistent on what you're going to see on your formula chart. Okay, so we've already figured out the perimeter of the base. We have that information over here. It was 28 times the height of the prism, we already figured out was 12, plus 2 times the area of the base. So that's what we need to figure out now. So I'm going to do my work up here. So the big B, that big B is area of the base. First, identify the shape, which we've already did was a triangle. Now we start with the area formula for a triangle. So we're going to say base times height divided by 2, or you'll see on your math chart 1/2 base times height. Whichever one works best for you, they both mean the same thing. I personally like this one, so I don't have to deal with multiplying with fraction. So your base of your triangle is 8, and your height is right here, and they have a little arrow as 4. Remember, your base and your height always form a right angle. It's never going to be slanted. So we needed that 10 for the perimeter of the base, but not for the area of the base triangle. Okay, so again, base and height always form a right angle. That's right there. So 8 times 4, base times height, divided by 2. So 8 times 4 is 32. 32 divided by 2 is 16. So now we have everything that we need. So we're going to go ahead and plug that into our calculator. So 28 times 12, which we already knew was 336, because that was our lateral surface area. So this makes sense. This is our lateral surface area plus the area of the two bases. So this is the area of one base. So that's why we're adding both of them. 2 times 16, because that's our total surface area. It's 32. So we'll add that all together. 336 plus 32 is 368. Sorry, I need to clean my phone. It's a little dirty. So I get 368 centimeters squared, or squared centimeters. And again, if you don't believe me that this works, you could visualize this and do this as a net. So see, this bottom rectangle is 12 by 8. 12 times 8 is 96. And then this one would be 12 times 10. 12 times 10 is 120. This rectangle back here would be the same, 12 times 10. So 120, if we check it out, 120 plus 120 plus 12 by 8 was 96. That's right there. And then those area of the triangles we already figured out was 16. So if you added all areas of those 5 shapes, you get it that way. So again, the reason why we showed you with the nets first is to kind of show you where these formulas came from instead of just throwing these formulas at you and you not understanding what they represent. Again, go through this video again if you have any questions, and please let us know if you need help at any time. Good luck on your assignment.